So this is just, I suppose, a bit of a summary of some thoughts I've had of the last many months playing, I suppose, with agents and trying to understand this domain. These are not all of my thoughts, but it's certainly one area which I think is it's definitely like worth having a chat about. And this is also like my view right now, which is like an incomplete one, right? I'm not actually an agentic development expert. I've tinkered a bit with these things. And there are probably other smarter people who have done more. Kieran and Archie certainly have done a whole lot more, and so maybe they're more authoritative. But I've played enough to get like a bit of a feel, to at least have enough of a feel to go, ooh, that could be better. And so this is one of the topics I thought could be a cool one to chat with you guys. And I suppose, unsurprisingly, it comes from my preference for type safety. So I was kind of grappling with with a title here. My first title was this: Building on Quicksand, Why Your Agents Suck. But I thought I'd be a bit more diplomatic and go with like type safety and agents. I will learn to stop worrying and love composition. So there's a few things here, but what I thought would be kind of cool is like, maybe not everyone knows what agents are. Like, I'm sure, and I don't think I know exactly what agents are either. So let's like start at like the lowest level. I've tried to, instead of like sitting at the kind of zoomed out level and say, well, agents can do this and automate and generate us some code. I was more interested in saying, like, how do they like properly work? I want to go and like see how they like, what is the role of the LLM in an agent? What is an agent? What are these tools that we talk about? And like go and like unpack that at like a low level. So I've tried to do that actually in these slides. It's like, let's go through a very simple agent, and hopefully everyone, and maybe I've got this completely wrong as well. So I would love for you guys to interrupt me, ask questions, and like, let's just explore what the hell are agents from scratch. So here's an example. It's like, we have a user. This is you. This is a person talking to an agent. And this is an agent, like it's the wrapped up agent, plus there's a whole lot of things inside this agent. This is what you might ask it: what's the weather in Amsterdam? And it may respond with, currently in Amsterdam, it's about 18 degrees and partly cloudy. Okay, so there's the example. So how does this actually work? Like, how do we break? How did this come about? So the first thing to know is that agents are not just these standalone single component things, but they're a composition of a bunch of things. It's almost like, and agents technically are like, you might think of an agent as some kind of artificial intelligence or some sort of LLM model or some sort of, it could be some model or some neural network. This agent is this intelligent thing. In fact, an agent is not the intelligent thing. An agent is just some software that orchestrates a bunch of things, one of which is an intelligent thing. And so I think at the sort of base level, and agents can be a little bit more than this, but I would say at the like fundamental level, they are built up with, and you can think of them as like an architecture as well. So the same way you can think of microservices as like, you can put a little ring around a microservice and say, well, this is the login service, and it requests, and you can send it requests and it will respond to login requests or whatever. But a microservice could depend on other microservices. And so you could start to say, well, actually the login service is more than just one service, kind of like a composition of services that allow it to do its single thing. So yes, although they're you can split them into smaller components, like they need to be put together for them to actually work. Agents, I think, are very similar. So an agent really is primarily a combination of two things. The one is tools. And tools are just, and we'll get into what are tools, but tools are just like software. It's like calls. You can make requests to APIs or run a function or do something like some kind of technical work, query a database, whatever. And so it's kind of a grouping term, as well as having access to an LLM. And that's where the intelligence comes from. So the agent itself is not intelligent. It is just software, but it is using an LLM to provide intelligence, as well as presenting those tools to the LLM to have it make decisions, right? The other very interesting part in this, I suppose, comes back to that earlier description around services is The same way services can speak to other services in a microservice architecture, agents can speak to other agents in an agentic architecture. And that shouldn't be too surprising. The interesting thing here is when we think of what do they present to the world, they have two things that they present to the world. Well, they have two different kinds of users that they present to. The first one is actually a human, where you are writing free text stuff to this agent. But then, of course, because agents can also service agents, they unfortunately present that same protocol to other agents. There's this kind of, so agents just believe that anyone calling them speaks text to them. And this I find to be a bit of a problem. And so I've like noted it there as interesting, but it's in red. So it's interesting in the negative sense. And we'll dig into more detail on that one. Any questions around what are agents? Does anyone have a different understanding of what is an agent? Yeah, go for it.
No, we had the discussion, didn't we? In the even the debate, if you will. So I think you're right. You're spot on now. So you can, in my view, you can think of an LLM as a disembodied brain.
Yeah.
Okay? So it's the piece of intelligence, but it's kind of useless. The only thing it can do is hear you and talk back. But it can't do anything on its own. It can't like move around the world, interact with the world. As soon as you give it tools, you give it agency. And that's when it becomes an agent.
Yeah, that's cool. That's a great description, because you can say, like, if you look at a human may seem intelligent, but if you look at its hand, like a hand is not necessarily intelligent. So you say, well, where does the intelligence come from? It comes from the brain part, right? But it's like kind of, that's a composition of a whole bunch of things. And as you zoom out, that intelligence remains part of the unit. But it's important to know the intelligence doesn't come from the hand, it comes from the brain part, right? When you trying to understand how they built. And especially one day when we think we can build these things, we should know with certainty that the intelligence is not part of the agent part, it's part of the LLM part, right?
And an agent, like a human, is an agent because we can act in the world. We can think and we can act and do stuff and observe stuff. And that makes us agentic.
Yes, cool. Exactly. Okay, so here's an example. Here's that same example that we started with. So like, how does it break down? And so just for the like notation here, the green parts are like the request part, and the red part, I suppose, is the response part. Those things happen in a weird sequence though. So a user may send a request to the agent saying, what's the weather in Amsterdam, right? This arrives at the agent. And keep in mind, the agent is not this intelligent thing. It is just software, right? So just move that away. So what does it do with that? Well, it has this LLM. So it sends that to the LLM, and it's got a set of tools. So that becomes a request, which is the same. What's the weather in Amsterdam? Exactly what the user provided. But he also adds in a list of tools available to that LLM. And I'm simplifying here. We'll get into the actual protocol, but this is conceptually what happens. So the agent makes a request to the LLM to say, hey, what's the weather in Amsterdam? Just literally passes it straight through, but it adds to it. It like injects the list of tools available to that request. So you can imagine it's just adding it to the string. This doesn't actually happen exactly like this, but conceptually. The LLM goes like, well, I don't know what the weather in Amsterdam is, right? So it literally replies like, I don't know what that is. I don't know what the weather is, because it's like an LLM doesn't know what the weather in Amsterdam is. It's just like a mathematical. It's a big like vector space, right? It doesn't know the weather, and so it responds saying, I don't know what the weather is, but I see that you have got access to a tool that might be interesting. So let me, in my response, ask you to run that tool for me, right? That's the response from the LLM back to the agent. The agent, just as software, goes, oh, look, you told me to run a tool. I don't, it doesn't interpret any of this junk here. And in fact, the LLM may not give it that junk, who knows? But it sees this run tool. It goes, oh, yes, I know how to run that because I'm software. So it runs it, right? It calls get weather Amsterdam, exactly what the LLM asked it to do. That little tool returns something, some kind of output. Maybe in this example, it's conditions partly cloudy with a temp C 18. That comes back to the agent, and the agent goes, okay, well, I've run it. It's got no intelligence, so it passes it straight back to the LLM. Again, the same request, what's the weather in Amsterdam? And this time, instead of it adding in the tools, it says, I've run the tool, get weather, and that returned the following output. And so now the LLM's got everything it needs. It goes, oh, cool. Like, you're really asking me something very stupid. What's the weather in Amsterdam? And you're giving me what the weather in Amsterdam is. So let me just put that back into English. Currently in Amsterdam, it's about 18 degrees and partly cloudy, back to the agent, and the agent just responds with that back to the human. So conceptually, this is how tools, agents, and LLMs work. Does that make sense to everybody or no? And can you see the intelligence? There is no intelligence inside the agent itself. Is that clear?
Mm-hmm.
It's not a question for you, Marie. Yes, sorry.
Cool. So sorry. So the agent basically just appends a little bit of extra context onto the request to the LLM, and the LLM then responds, and the agent just knows how to accept that response or pass that response and give it to the user.
Yeah, exactly. Yeah, exactly right. So this agent part in the middle is not intelligent. It can speak to something intelligent. So its protocol is effectively like just add the list of tools into the requests. And when an LLM responds with some kind of like mechanical way of running those tools, then run those tools and add the output into a request which contains that output back to the LLM. So it's not doing anything intelligent, effectively. It's just kind of providing an API for the. So if you think about it, the LLM kind of requested to run that tool, just happened to do it in the response of the request, I suppose. So it didn't actively like initiate. It did initiate it, but it was on the back of a response initiated by the agent. Yeah. Okay, but I think that kind of makes sense, right? Anyone else have any issues with that? We'll get into more detail next. This is the conceptual. Yeah, happy? Okay, cool. Any issues we can see yet? Does anyone see, like, this definitely does work? But anything weird there?
It's quite weird that it's all text-based, right? So
yeah,
like
that is weird,
in
right?
that agent software, you've got to like pull out what the LLM wants to execute and then like go and execute that. That's not ideal.
Yeah, unideal, absolutely. Yeah. I think when we look at it in more detail, you see some of that is partially dealt with. It's like it is separated out a little bit. There is a bit of a protocol, but it is a problem, Matt, for sure. Yeah.
Yeah, indeed. The software that needs to ultimately make the call out to a tool needs to do it in a predictable way and need to know how to call an API, but needs to call the API correctly. Yeah. So yes, your LLM needs to respond in a way that's interpretable by very sort of normal code.
Yeah.
Yes, exactly. In order to invoke the call. So yes, it must be like the LLM must be very strict in how it produces the API call parameters.
Yeah.
But the other software must interpret and parse.
So I think what Marez is drawing attention to is like this call here, get weather Amsterdam, right? It's like the LLM could have put whatever the hell it wanted here. It happened to put the city name there, but like what told it that needs to be the city name? And if it put something other than a city name, this agent has got very little, it can't interpret this. It's just a string, right? And there's no intelligence at the agent. So it is beholden on the agent to make sure that that parameter is kind of a valid parameter, because you could be doing something nefarious up here. When you execute this tool, you could imagine this. I mean, fine, this get weather Amsterdam is very simple, but there could be some injection potential here. You could inject something because this Amsterdam may make its way into a SQL query or something else. And so you've got to be like, care needs to be taken, right, around.
No, of course, you want a banking agent, Yeah. You want ultimately a banking agent that updates, that sends payments instructions.
Yes.
Imagine an injection attack there.
Yeah.
Change the bank account number.
Exactly. So there's the potential for those things to go funny, and we have to think carefully about that. The other interesting thing, and we'll get into it in more detail, but like when this LLM executed get weather, it had no concept of what the output could look like, right?
Yeah.
It's just saying,
so like,
call this function and just hope to God that it gives us something useful. And it only actually got to know what that output was on the like subsequent request. There was no way, like there was no schema effectively for this call. It just knows it's got a function called get weather with city name. And it doesn't know what that could respond with. Like it didn't know that it would get back a temperature and a conditions. It may have just gotten back a temperature, or it may have gotten just a conditions, or it could have gotten raining equals false or something, right? It had no concept of what the result of that call could look like. And so this LLM is a little bit shooting in the dark. It's like hoping it's calling a function that looks like it could be right. There's no way of confirming that it is going to give it what it really is being asked to provide, which I think is maybe more my fundamental issue with this thing. But we'll carry on. Yeah. Anything else?
Tom, sorry, just from my side. So one thing is, well, like I've been running this agent now kind of in Claude connected to my local Kubernetes cluster at home. Yes. And a good example of how dumb it is, is I'm like, okay, get me the pod logs. And it's like, you have no pods. And I'm like, but I have pods. Here's the list of pods. Oh, they are in different namespaces. So it looked at default namespace. But I mean, once you've gone through one or two of those iterations, I can now literally just say, hey, there's an issue on my Plex server. And it knows now, okay, go in there, go into the media namespace, go and get the logs, come back with her.
Yeah.
But it's quite nice. Like I love the troubleshooting aspect of it. It's like just, go through, scan my entire cluster, find any issues, and tell me how to fix them.
Yes. And they are expected to work quite well because Kubernetes is kind of well understood, and probably the LLM understands Kubernetes. So it would be technically quite intelligent, I would think. Sorry, someone else was talking.
Another question. Sorry.
Yeah.
So like the way I'm understanding that is like we spoke about the request side, but what about the response side? Like it's returning like some JSON that says cool conditions partly cloudy, but is the agent in some way expected to define or parse that let's say JSON file, right? But like do we define types in the agent that it's expecting a response like that? And how does the LLM generate an exact response like that in a sense? It's like, how do you predict that it's going to build that JSON in that format or that form?
So when you execute a tool up here, this execution of get weather Amsterdam, this is just software. So that is that is the output of whatever this get weather Amsterdam, like you can imagine it's a Python function, right? There's no intelligence there. That's just like the tool outputs in that format. What's interesting is in my example, I'm making an output in like a JSON format, but there's absolutely nothing that makes this have to be JSON. It could be absolutely anything. And that's a good thing and also a bit of a bad thing, because only by the time that response gets to the LLM is intelligent, so it can interpret it. It can say, oh, this is JSON. That's cool. I can understand that. And even if it was badly formed JSON, it would probably still understand it. Or if it was an XML, it would understand it. If it was CSV, it would understand it. Or even if it was just written as text, it would understand it. And that's the great thing about an LLM, right? It brings this like ability to interpret stuff that is unstructured, which is amazing. But I think we rely on that heavily, because what it means, us as developers, we can output whatever the hell we want, because generally the LLM will interpret it fine. And although that's a good thing, I think that's also a bit of a bad thing. A bit of a bad thing. But we'll see. Yeah, let's carry on. Okay, so I think I just zoom into more detail. So it's like each one of these little steps, let's have a look at it actually on like the wire protocol between agent and LLM. I think the protocol was made popular by OpenAI. So this is, I think it's called ChatML, this kind of format, but this is changing over time as well. And this is different depending on provider. There are like projects to try and make a common LLM format. because there's like a small number of strong players, they all kind of do their own thing, and there's just a whole bunch of open source projects to try and make them the same. But this is, I think, is OpenAI's protocol to their LLM. So this is the initial request, which would be this one here. What's the weather in Amsterdam, from the agent going to the LLM, where it's put in the tools. And so this is what it physically looks like. You can see it's not actually adding strings together, but it's more this array of messages. So you'll see messages as an array, and this is because it's chat-ML. So chat meaning conversational, means there's like there could be multiple parties in this chat. You'll see there's a system message, which is often just given to kind of give the LLM some background, give it its context, have it behave in a certain way. That's the system prompt, and then the user prompt. So the system prompt is like, you are a weather agent, you are helpful. You will see this always. You are a helpful assistant. Weather queries, your goal is to provide clear, accurate weather updates, and you have a backstory sometimes. This is made popular by Crew AI, that you provide backstories to agents. So fine. Okay, so that's the system prompt. What the user actually asked for was, what's the weather like in Amsterdam, right? And that came directly from the user there. And this is it adding, this is now my agent adding the available tools into the request to the LLM. And OpenAI structure is, you provide this like tools list, a list of tools. I think, I'm not sure the exact format here, but it kind of makes sense, right? You can see there's a function called get weather, there's a description, what its parameters are. Parameters is an object with a city property, which is a string. So that's cool. And then you can also say, well, what is required and what is optional? I suppose you could have multiple parameters here. Maybe a city, state, continent, and state doesn't make sense for non-US. So you could make it optional. So that's totally fine. You'll notice here, so, okay, so then the LLM receives this request. So the request is, what's the weather in Amsterdam? And, oh, you have access to this list of tools. The agent, so the agent, I mean, the LLM gets to know about all the tools and the inputs that it's required to populate them, but it doesn't get to see the outputs. Its response now we're looking at the response. So this is that first response back to the agent. Doesn't yet know the weather, but it wants to run the tool. Looks a bit like this. I won't dig into it, but you can see that it's adding a message saying the assistant, which is the LLM, wants to call the tool, and it gives it an ID, and it's saying, I want to call the get weather function with this set of arguments, city equals Amsterdam. Remember, it was like a Python object, so that's kind of why I suppose it's formatted like an object there, but it's a string. It's JSON, I suppose, embedded as arguments. Okay, so that's back to the agent. Now we know the agent goes and invokes that tool, calls the get weather function, gets a response. So the next thing that goes to the LLM is, it's almost all the same. So same system prompt, same user prompt, but now we see the request from the LLM going in, because it's conversational, right? So when the request goes in to the LLM, remember the LLM is stateless. It doesn't know what the prior request was. So the agent is like building up a conversational history, I suppose, to the LLM. So it's inserting the fact that the assistant asked to execute the tool as an assistant, but then it also adds a new entry in there, which is saying there was a tool which was called get weather, and its output was temperature conditions partly cloudy. Right, so there you can see there's the request, there was the request to execute the tool, and here is the response of that tool. Yeah, I think I'll zoom it up there. Yeah. And of course, because all requests going to the LLM from the agent always include all the tools available, we see all the tools available again attached onto the bottom. Yeah. And then, of course, it's very simple. Yes. The LLM then has got everything it needs, and it says, cool. Like the response will just be, me as the assistant, here is my content, currently in Amsterdam, whatever, and it completes the approach, and no longer asks to invoke a tool. right, in its response. That's its final response. The agent now goes, oh, you're not asking to execute a tool. This is your final response. So what must I do with it? Probably write it back to the user that initiated the request. Yeah. That's like, how simple are agents, guys?
Like well, you just need to be able to make those tool calls when you get back the response from the LLM saying, hey, I need this info from this other outside tool. Please make that call and send me the results back so I can interpret it for you.
Yes.
Interesting thing though.
Yeah.
We see what goes in here as a JSON structure, but that is not necessarily what goes into the context of the LLM. I mean, not that format.
Sure. Oh, sure,
the
sure,
stuff
sure.
inside.
Yes, this is, yes, correct. Yes. What you're saying, this is OpenAI's API.
That's an API protocol.
This is their API.
They'll pick it out,
correct.
Format it into a context, send that context to the model, get a response, create a JSON response object again.
Yeah, quite right. Yeah. And they could have, without making this too complicated, in fact, this could be run by an agent on their side as well. Behind this API. Yeah.
I mean, in fact, they could, for example, say, okay, and they do that at the moment, have built-in tools on their side where you either could say, you know, you're allowed to use your internal tools or, you know, don't care or don't use it. But if you say allow your internal tools, it could like probably short circuit and don't come all the way back to you to use your tool, use the internal tool to do some lookups, and then only respond to you once they've used the internal tool.
Correct, yes. But don't make it complicated, Marie.
No, sorry. I would say, like, I think the key to understand what an agent is doing is, on the LLM side, it's context engineering. It's doing context engineering in order to look like it's like acting autonomously. Context engineering and to and from the LLM all the time.
Yes.
To act intelligently.
Okay, good. So now we all know how agents work. So now I was interested in like this from a type safety perspective. And you'll remember the title was not how do agents work, but type safety in agents. And so like, let's think of the types actually. So this weather agent, which is this dude over here, it's like, what are its inputs and output? Like, let's just think about its types from an input-output perspective. I put inputs here before the arrow and outputs on the other side of the arrow. So the left side is the inputs, right side is the outputs. And it's like, unfortunately, like if we look at this user using this agent, it's like it's text in and it's text out, right? So its type is kind of text to text or string to string or whatever you call it. The interesting thing is like sometimes that text is JSON, right? Could be. Sometimes it can be JSON, right? But like text is the thing. Okay, that's fine. Let's look at how do tools look. Tools are better from a type safety perspective because at least the tools have got kind of, the types are well understood. The input types, we knew that on our get weather one, it was like an object with a city, which is a string, and its output was an object with a temperature in Celsius and a condition as a string. So that's cool, actually. That is like fairly well typed. I make it orange though on this side because, so I make this one up here, these inputs and outputs for the weather agent orange because like text is like saying, let's just make everything a string. And then if we want actual structure, we'll just like, we'll encode it in the string. Just feels like a bad thing. We used to do this a million years ago and we convinced ourselves, right? Matt, other good developers out there, is this a good idea to like make every field a string and put whatever data you want because you can encode it in a string? So that's great, right? Then everything should just be a string. In fact, our database should just be like one table with one field called data, and it's just a varchar, right, of 1 million, and you put whatever the hell you want in it. I think that's not great. Yeah, equal light. Yes, let's not go there. And so I don't think that's strong. I make this green because I think that is strong. It's like we know there's a city. I make this yellow because the LLM didn't actually know the outputs of running this tool. Like it knew that there was a tool called Get City with the weather. It didn't know what it would get from it. So it was kind of in the dark for, it executes it, it knows what it has to provide, has no idea what it could get from it until it actually gets it. And then it goes, oh, okay, that was the type, that was the response. And so that also feels a little weak to me. Like, wouldn't it be nice had you known what your output could be? So if we had to improve this, what would we, oh yes, another downside of this is this text to text for agent is fine in this situation where you have a user calling the agent and responding, because users find they can generally talk text. That's okay. Humans can talk text. But what about in the situation where you have an agent invoking another agent? It kind of sucks that this agent calling this agent has to deal with text. And like, wouldn't it be nice if that was structured? Wouldn't it be nice that if you're invoking an agent, you would know upfront what it requires when you call it and what it would give you in the response, so that because you are just software as an agent, wouldn't it be nice that you could just parse that yourself as opposed to having your LLM interpret it? Anyway, so let's reinvent it. So wouldn't it be nice if your weather agent was rather parameterized on the type here, and it's parameterized on its output type, which is kind of weird. So I'm trying to make this Java-ish, maybe it's C#-ish, but then I've screwed it up by making that look Haskell-ish or JavaScript-ish. But imagine your weather agent, when you invoked the weather agent, you could tell it what the output type that you're expecting looked like. You could parameterize the output type. Maybe you could parameterize the input type as well. Yeah, probably as well. I'm trying to keep it simple. So for humans, you could set the T equal to text, because humans speak text in and they're happy to accept text out. So it would look like that. But if it was an agent calling you, wouldn't it be nice if you could say, well, I want the output to just be an object with a description in it. So when I invoke you, I expect that you output that type of structure. And so for an agent calling it, it would be a text to an object containing a description, like a JSON structure or whatever. Or it could even be that like something completely weird, like maybe as a weather agent, I want to give you text and I want to get a list of temperatures per hour or something, right? Wouldn't that also be nice? So it's like, is it weird that I'm parameterizing the output type? That should feel weird to you. Yeah, not the input type. Kind of weird, right? But I think this is the magical, cool thing we can do with agents. But does this example make sense? So like then I could use the same weather agent, say, actually, I want a description of what the weather looks like right now. I don't care about the temperature. I just want a description. Is it partly cloudy? Or maybe I can use the same agent and say, I'm going to ask you a question, but I expect a list of records by hour, temperature by hour. That's like a very different question. It's the same question. It's just like, I want things in a different format. Format as well as informing the agent or informing the LLM what it is that you're wanting from it. And potentially it may run different tools depending on the required format. This is where stuff gets wild, right? Even Marais is silent now.
No, I mean, this makes sense when you have your LLM, which is essentially stochastic, and produce anything. You want to kind of force it to produce it in a particular format. Because you know that you may want to parse this using regular old code and not trip up on some response that wasn't like formatted very specifically.
So do you see that it's more than just format? These are actually two different, very different requests. The one is like, I want the weather, but just as a description. This one, I want the weather, but I want it by hour, maybe over some period. And because the LLM can know about this output format, it may invoke many very different tools to achieve that. So in fact, we're asking it's not just a syntax thing, it's a semantic thing as well. We're providing
we're asking it two different questions.
They're very different questions. Yeah.
They're different questions.
Yeah. So this one may run one tool, whereas this one may run 10 tools because it needs to produce it by hour. So they're semantically very different. They're not just syntactic. And that's what I think the very cool opportunity here is. Okay, so then I've got a demo to show you, but I think that's the last, there's a few things. I'll show you a demo. So how could this potentially work is like, say, effectively, when the agent calls the LLM, just inject the schema of that type into the request. So when I'm asking an LLM to do something, I should inject the output schema into that request. When the LLM then convince the LLM that it must respond in that schema. The agent then is very stupid. It just tries to parse it as that type. If that fails, for whatever reason, there's a parse error, it's cool. We can go back to the LLM, tell it failed, have it try again or whatever. So it can also have this like feedback loop of achieving the right output format. And then returning type T to that caller. So whoever called you, it could be a user, it could be another agent, doesn't matter. They're expecting a response of type T. Yeah. Okay, so why is this good? And in my experience, the very cool thing I see about this idea is that we can reduce our context size, because instead of like the old approach, or the current approach, I should say, is often the way you convince an LLM to give you stuff in a particular format is you give it an example. You say that I expect it in this format. Maybe you give it one or more examples. By giving it a schema, you don't need to give it examples anymore. It's like completely communicated to the LLM. It needs to be in this format. Or, a good schema language would also inform it of every data type. All the optionality would be in there, etc. So you don't need to give it examples where it's like, oh, this is one where I gave it to you over 10 hours and it's by an hour. And here's one where it's just very simple or whatever. You don't have to give it all these different alternatives. You just give it a schema. And the LLM, smart enough LLMs can figure out all the alternatives. The other very cool thing about this is when you have text to text, the issue here is like decoherence can occur. Like when there is error starting to propagate, there's no way to pick that up early. So like that text just flows into the next text, into the next text, into the next text, especially when this thing is agentically doing multiple steps. Maybe you have an input, it goes to a tool, you get an output, the LLM then, I don't know, outputs something, and you have another agent which then handles that more downstream, and everything is just text to text to text to text. Any errors in that text just propagate throughout your whole agent lifecycle. Whereas when you set the output format, any error in that format is picked up immediately. So you reduce this decoherence, like agents getting doffer as this like multi-generational problem of agents calling agents or handing off between each other. When you have stricter data types, you pick up errors kind of immediately, as opposed to much later on when you realize they're now booking you a flight to Portugal. And it's like, oh my God, I just, was trying to check my email or something. I think.
The detection of
very specifically what happened to you, Tom.
Yeah.
the detection of the errors, that is because you will immediately try and pause the response with this validator or something. Okay. Yeah.
Yes.
Exactly. You'll do that.
Exactly.
But most of the times,
exactly.
I suppose, if you expect output in a certain format, is because you are going to parse it in any case, in which case it will fail.
That is up to you as a developer, right?
That is obviously, yes.
Yeah. But what I've seen a bunch of is you get an LLM to output you some JSON. You don't parse it yet because you want it to, you have a guardrail or something. And guess what? A guardrail is implemented as another agent. You just pass the output straight to the next agent and you say, is this now valid? Yes, it is. And only then do you parse it, right? So it's kind of, you can waste multiple generation steps by not picking up issues earlier. But yes, if you were a good developer, you would parse it first.
Immediately, Okay.
Yeah, this kind of forces you to, I suppose. Okay, I think we deal with that. Oh, the other, and then the last most important thing is that agents become composable. And so what does composable mean? And it's like, compose is a very simple concept. It's like, if you have a type that goes from A to B, and you have another type that goes from B to C, then you can probably create another type which goes from A to C. Like, that is composition. Like, does that make sense? I think anyone who's done my Haskell stuff knows composition backwards. But like, if you've got something that goes from A to B and something that goes from B to C, then you also have something that goes from A to C, right? Because you just compose those two things together and you have a bigger thing. Yeah, that is what composition is. And now we are doing that. We're saying we can parameterize both sides. I don't show you the input side, but there's no reason why not. You have something that can go from something to something, and later on you may have something that goes from that same something to something else. Then of course you can compose those things together. And so diagrammatically you have this building, you're creating a building block. At the lowest level, an agent is a very dumb thing that maybe just does one specific thing. As soon as you glue it to another agent, you can create a bigger agent out of smaller agents through this idea of composition, right? So it could be down here, we've got the weather agent, which is figuring out the weather in this little red boxy thing. Maybe further upstream, we've got something like a travel planning agent or a flight booking agent. And then right up front, we've got like a holiday planning agent. And at the end of it, because everything is parameterized by type, you can compose them from smaller blocks. So it's like creating Lego blocks. Yeah. Everyone is convinced that composition is good, right? Everyone builds software using composition, correct?
Aye, Captain.
Using objects. Or do others use objects?
How's the weather, Tom?
It's a good thing. It is a good thing. I will convince you. Okay, demo. So here is my standard apology, but like it is written in Haskell, I'm going to read this to you. And so it may be hard to read. Haskell is a great language to play with types and stuff. And many good discoveries come from Haskell, like async await, list comprehensions, lazy and generators, linear types in Rust, option types in Rust, link in C#. These all came from Haskell. So you have to tolerate Haskell for advanced type specific things. But this example I will show you today is completely reproducible in whatever language you like. It's not a Haskell specific solution. But so what I've done is I've just written a cool little library which looks like this. So this is shaky hand composition. We can run a composition and we can extract something. So I could say, so prompt just means kind of like prompt, the beginning of a prompt to an LLM. What I'm adding here is I'm saying, I'm being specific about the output type. That's what extract does, is it's saying I expect a text as the output type. I'm obviously giving you a text because humans, this is just a human example inputting stuff. The human always gives text, so that's the string on the right. I want to run an LLM and I expect to get text as the output. This is right now wired up to Anthropic, so it's using Sonnet 4, I think. But it works perfectly fine with ChatGPT as well. But the cool thing is I can now start to parameterize the thing here that I expect from it. So I could say, hello, and I expect an integer, for example. And it says naught. So like its answer to hello is naught, but I could ask a different question like what is, I don't know, 40 plus 10 or something, something very basic. And I get 50. So you can see there is some intelligence happening there. If this was text, we would maybe see a different response. That's 50 now as a string. Okay, that's cool. This gets exciting when you start to say, well, can't I use interesting data structures, right? So here is this in Haskell is exactly how you would interpret in any other language. A joke is a class, and it has 3 fields. All of them are text strings, genre, setup, punchline. So we can use this type as well. I can say like, I want a joke out. Tell me a dad joke. And so it returns with an object in that structure. Joke, genre, setup, punchline. Cool. Here's something also very interesting. What if I want like a array of jokes? Tell me a few dad jokes. And it's like, oh, cool. Now it returns a list. So there's a joke there, another joke there somewhere, another joke there. There's like 5 jokes. Could be tell me 2 jokes, whatever. And it's because I've told it I want a list, it kind of knows what to do. Another interesting one could be like, give me a couple of jokes. And just like tell me a joke. Tell me, I don't know. And here we're saying I want a tuple, which is like, there's a first element and a second element. They're both of type joke. And the LLM goes, yeah, I know. Like there's only one solution to this is to return a tuple which has got exactly 2 jokes in it, right? And that's what it has done. Even though I told it to ask it to tell me a joke, there's no other solution. It couldn't come up with a way with like leaving the one out because that doesn't match the type system, right? It's like strictly enforce this. We could even just say like do whatever, and just through the fact that we've asked it to respond in that schema, it kind of knows. I didn't need to tell it about a joke. It's like it had to give me 2 jokes, right? So that's quite this is that like semantic thing. In fact, I could probably just give it like an empty string. And it's like I'm communicating information through the data structures, right, to the LLM. Does that make sense? Is that cool?
Very clever LLM.
Isn't that cool? It's like we're using the data types here to do interesting stuff. So I've got like a different kind of joke. This is like a more advanced, this in another language might be like an enum. There's only 4 different variants of jokes. A dad joke, one-liner story, knock knock, and they've got different parameters depending on which enum variant you pick. Yeah, I think you can do that in C#. I think Java as well, right? Of course, this thing is super smart. So it's like, well, I don't know, tell me a dad joke. And so it will pick, hopefully, the correct variant, which will be called dad joke. Yeah, so it is a dad joke, which has got a setup and a punchline. Correct. The interesting thing here is like, I could also, and of course I can do all the other tricks, but I could also like inject stuff. So I could inject there's another function called inject, which composes like another structure here, which could be that original joke type, which is like, I don't know, a dad joke. It has these 3 fields, right? A genre, setup, and a punchline. The setup is, I don't know, I'll just say setup and punchline, so I'll give it garbage. Tell it to extract the better joke and tell it to do it. And let's see what it thinks. And there it's done it. So it's like it's converted from the one data structure to the other data structure. So it went from a joke with those 3 fields to a better joke, which has got actually variants, right? That seem cool. I think that's quite cool. Let's use some other cool examples. What about if we go run prompt and like check here, here's like an application form. We have a name, an age, and a marital status. Marital status is one of these 3. You're either married, unmarried, or widowed. So let's have it to, okay, so we'll extract an application form and we say like, fill this in. But we're giving it very little, so it's probably going to creatively do something. So it says, cool, John Smith, 30, unmarried. Okay, that's cool. What if we tell it a bit more? So inject, let's go Mike, Grant, how old are you, Mike? 40, married. What if we just give it?
Plus a few years, right?
Well, I'd leave it at that. 39, right?
I love it.
Give it like a. Getting a little warning there just because of the type. Don't worry about that. But it's gone from. I can fix it if you want it fixed. No, so it's like there we've just injected something. So it's like it could be that. We could of course say, well, actually extract a list here, and let's inject a com chart my whatever. And there it's like filled in a form for the three of us, and it's invented the other fields, which is weird. Married. How old are you, chart? You're 40, right? No, you're 30, 37. I'm
early
40, 43. You know, like, let's just give it garbage. But because we're asking it to extract it into this format, it kind of just does it. It knows what to do. Okay, so that's like the very fundamental basics. Here's something like quite interesting where we start to compose these things into bigger agents. So say, and here I've called it Dino project. So imagine, okay, so it's an agent that can complete a dinosaur project. Like imagine for your school, like you're a 12-year-old and you've got to present a dinosaur project to your class. This is that agent. That agent is made up of a bunch of little sub-agents. The first one is a suggesting dinos agent. So it's an agent that will suggest 3 names for my grade 5 project. Then there's a research agent, which will research the dinosaur. Then there's a draw pick agent, which will draw an ASCII picture of it, 10 lines high. Then there's one that will build a trump card. I know it's a bad word, but this is what they're called, right? Trump cards, which will output a trump card for the dinosaur. Then there's a final build poster agent, which will take all of those things and create a poster from them. And you can see the types here. So the suggesting gives you a list of text. The research gives you a dino. What is a dino? A dino has a name and a description. Then the draw pick gives you a dino pick. A dino pick is a very stupid type, but it's just got an ASCII pick as one record. Then the trump card has got these 5 fields, like a size, velocity, speed, intelligence, armor, all integers, also kind of dumb, but kind of cool. And then the build poster guy goes from a list of dinos to dino pick to trump card. So it'll be a list. Each element in the list will have a dino, which is that description, a picture of the dinosaur, and a trump card of the dinosaur. And the final type must be text. And there's the composition operators. This little thing here is a bit magical, but it effectively does this in parallel. So it'll run the suggest first, which will give us 3 dinosaur names. Then in parallel, and I mean truly parallel, like threaded parallel, it will run the research, the draw pick, and the build trump card in parallel. So all 3 of those all at the same time, times by 3. So we'll have 9 requests all going in parallel. That will come back together and it'll build the poster finally. So let's run this guy. Run Dino project with nothing because, and then I must just remember to print this properly. I'm not unpack, I think. Variable not in scope, text to string. What am I doing funny here? I think I'm not going data.text on the unpack. Yeah, sorry, unpack I hadn't imported. Okay, so now we're running Dino project, which is all of the composition of this whole big agentic thing, some of it running in parallel. I can show you the inner workings if you like, but you probably just want to see the dinosaur poster because that's the best part. Should probably print some like interim request response stuff or something. And hopefully it's working. There we go. So what did it give us? The Tyrannosaurus Rex has got
size 10 out of 10.
There's our ASCII picture. There's the description. Triceratops. That kind of looks like a Triceratops. Pretty good,
that's
actually.
pretty good.
Stegosaurus. Wonderful,
Stegosaurus
right?
is so good.
That is absolutely perfect.
That is
cool,
amazing.
Right?
We should use this in team building where you choose what kind of dinosaur are you.
Yeah.
It's a caricature.
Wonderful. I love it.
Thin legs.
So cool.
So then the question you should have to me is you should say to me, but Tom, what about tools? Like, how does this thing run tools? And it's like, guys, it's the same. Oh yeah, I've got some other very cool examples. Like I've got an example of it playing tic-tac-toe against itself because it can. Like, actually, this is quite a cool one to run this. And I think I print, yes. So we can run this play tic-tac-toe game. I think I just run it. Yeah. And I think, oh, it prints badly. I've added this like stupid progress printer thingy, which kind of mangles the output sometimes. I need to do that better. But here, effectively, what this little agent is doing is you'll see it's kind of a while loop. So it's saying while the game is not ended, just inject the game. So run a prompt where I inject the current game state and extract a new game state. And just keep doing that until the state becomes ended. And this is the starting state. So what does a game look like? A game of these types. A game has a board and a game state. A board is, so the game state is the simple one. Either you are playing the game or you've ended the game. A board has got 3 rows. A row has got 3 spaces, and a space is either blank, an X, or an O. So that's quite a detailed description of a tic-tac-toe game, right? Noughts and crosses, right? Probably could be better, but I've over-engineered it. And I just asked the LLM to just run this. So it starts with an empty game state, and you'll see the first response from it is probably it laying the X somewhere. Yeah, there we go. There's the first response from it. Let's put the X in like the top left. Then the next iteration, O gets played at center position. Then the next X goes bottom left down there. Then the next O goes to top right. And then the next X goes to bottom center. And then it probably, I don't think anyone wins. They hardly ever win. But like the game becomes stalemated and that's the end, right? But like there's an agent that just runs a while loop over a game state. Then the last one to show you, this I think is kind of cool. It's like, okay, but what if I wanted to introduce tools into this thing? Well, it's like I haven't changed anything other than saying, well, tools are just another data type. You just declare one. A tool has got different variants. Either you can list files or you search the web or you set some volume. This is just an example. When I ask an LLM to do something, either when it responds, it must say either I'm not running a tool and I'm just giving you the answer, or I'd like to use a tool and it must be of the type of that tool. After tool call is now, after I run the tool, I provide the results of that tool back to the LLM. And then finally, oh yes, well, after running, I give it the results of the tool for the input type and of type R, which is the result of that tool. So it's like a little bit complicated, but these are the inputs to the tools. These are the tools you can run. These are its outputs, effectively. And then there's kind of wrapping up of whether you've run a tool or once I'm giving you the after effects of a tool as just as other types. And without changing anything in my cool little language, which allows you to inject objects and extract objects, it's like, here's how you can run tools, nothing more. So we can try it, prompt. And we'll just go with tools. What is my tool type? I think it's, my tools, sorry. There, it's my tools. Extract some text. Finally, maybe that's the final type. Hello, let's just try this. We'll just run a hello and we say, hey, you've got access to tools. Probably won't choose to run a tool. It just responds with hello, how are you? But it's like, hello, maybe I could ask something else. Hello, what should I say? Set the volume to minimum or something. And hopefully now it goes, and there's the interim call, like the LLM request to call the tool set volume 0, and then it does finally reply with the volume has been set to 0. And then like, so it's like we could extract, okay, fine, text. Also like what files do I have? We could ask it to run another tool, which will hopefully run the list files tool. Yeah, request to call the tool list files. There we list the files. It's like great, works perfectly. So that's how simple like tool use could be with a type-safe agentic API.
Amazing.
Yeah. Yeah, here's just another
Nice.
example. Yeah. But that's it. That's type safety and agents, and not just type safety, but something a little bit more, adding semantic meaning into what we ask our agents to do through communicating with them via types, I think is awesome.